We are now on a laboratory number 2, which is Gauss-Jordan method using MATLAB. For introduction, this activity will allow students to implement Gauss-Jordan method using MATLAB, Mathematica, or similar software. For objectives are, at the end of this activity, the students are expected to have been able to construct a function script using MATLAB, demonstrate your understanding in solving system of linear equations, understand and implement Gauss-Jordan method to find solution to system of linear equation using software. Materials needed are MATLAB, Mathematica, or similar software. This is our procedure. The pseudocode can be found in Numerical Mathematics and Computing, 6th edition Ward, Cheney, David Kincaid, page 266 that is shown below. Procedure number 2, it contains matrix of equation and we're going to solve it using MATLAB. So in our first part of this first code to do this end, this is for a piloting in Gauss-Jordan method. From this code to here, this portion is converts elements below in the major diagonal to zeros. From this code to here, this portion is converts elements above in the major diagonal zeros. From this code to is converts elements in the major diagonal of our matrix to ones. The last part of our code is to display a result. Since I've been doing this quite a while now, I've come to laboratory and going to typing of our own system. So now we are going to run the file. Here's our other document. So here it is just executed the Gauss-Jordan method. Our answer on x sub 1 is negative 1, 0, 9, 4, 7. For x sub 2 is 0.1053. For x sub 3, it is negative 0.4421. Lastly, x sub 4 is 1.9158. For question number 1, suppose a zero-valued coefficient is placed in the elements row 1 and column 1 of the matrix. How would that be corrected? The answer is the program will give you an error mismatch in dimension 2 for elements being concatenated along dimension 1. You must place a non-zero elements for it to work. For question number 2, there's a lot of ways to implement Gauss-Jordan method since the operations are not fixed for every matrix. Explain why you choose to implement it that way. What are the advantages and disadvantages of your program? The answer is through trial and error, I made progress in creating this program. The advantages of it is that I made it on a cascading manners in which the steps of the pseudocode could be easily read and understand by the user. The disadvantages might not work for everyone. Lastly, what can you conclude from this activity? I therefore conclude that the MATLAB and FreeMath can be used pseudocode programs to learn numerical methods. And that is all for today. I hope you learned a lot. Bye!